Welcome to my channel. It's been a while since I last posted a video. Could be because of life. Well, it's been a busy year. Anyway, um, lately I got to think. Um, I learned how to develop for the web, but I feel it's not enough. With AI and all, plus the competition, I say, well, if I were to switch, what would satisfy me the most? So I decided to have a go at C++. Hopefully I can make it to things like simulations. Well, what I'm about to demo is a simulation in its own regard. Simulations or embedded engineering, really. Thinking of the rise in EVs and all that. Hopefully I get that far. Anyway, my prior experience is in Python and C#. I know C and JavaScript, but I picked this up 2 weeks ago and decided to see how the fundamentals are, so that I would go from there. And but at this point, I've already been able to understand how to implement separation of concerns, object orientation, encapsulation, polymorphism, and the like. So with me here today, I have an ATM simulation of sorts. Let's see how it works. I'll first take you through a demo, or rather let me explain the source. Right here, this is my main file. In my main file, I have included the necessary imports, and because everyone agrees using namespace is evil and exposes the program to so many issues, so I decided to use my namespaces more strictly, just using only the things I need. In my main or entry point, I have this class here, and it's a class of a bank account. I have the header file here, and in the header file I've defined or declared the skeleton of the bank account, making the account holder private properties and exposing the methods, starting with the constructor, check balance deposit, a getter for the account holder, a setter for the account holder, set account number, set account holder, withdraw. So for now, that's all in my class. Back to the main, in the entry point, I've created an object from the class bank account. I've called that object bank account A. I've given it a name because I have to specify an account holder here. I have to specify the account number and the opening balance. So in my entry point, when I create the object, I pass these three parameters: the name, the account number, and the starting balance. After I initialize or create that object, I declared this option, printed out a message, and I started a do-while loop. In the do-while loop, I'm simply calling a function, a utility function, to show the menu for this ATM. And after it shows, because it's a menu, I've implemented its header here in this file, and I've implemented the menu here. So it will show you options 1, 2, 3, and 4, and ask you to make an option, a selection, and that number you make will be stored in the variable option. and I'll clear screen. So we walk through a switch statement here that plays out different scenarios. If you choose one, I display your bank account balance. If you choose to, well, I'll ask you to enter your deposit. That deposit is temporarily held in this variable, and later on, the deposit amount gets added to your account balance through the deposit method we created in our class implementations. So this, for every method in the class, this file details the implementation, and when you look at them, well, I was confused how a language does this, but this is the way in C++. You have the header and you have the implementation. So the header for the bank account class simply defines the skeleton or blueprint, literally, and in the implementation, I have to define all those methods, and starting with the constructor and all the methods, all I have to do is include the header file where my skeleton is, similar to what we did with a utility function that shows the menu. I create the header file. I create an implementation file where I include I didn't actually include it here. Interesting. So bank account header file, bank account, there it is. Surprising, yes, because this is a class, but this is just a function, so I don't have to put it here again. I don't think it would have any harm if I just put it. Let's see what happens. Let's include, it's called utility functions.h there. So because this is not a class, to say it's not a namespace, I'm not invoking it in any way, it doesn't make a change to the code. So like that, all features were implemented, and in the entry point in my main file, when I call on them, things work as expected. So when I run this program, just a moment, need to make sure you can see what I'm seeing. I can see my main, and it prints out the messages as expected, and it asks me to enter one of the options defined. If I enter the first option, it should display the minimum balance we start the account with, and it does. So if I choose option 2 to make a deposit, and I choose to make a deposit of 200, that also works. If I check my balance one more time, I can see I've went from 500 to 700. And if I choose option 3 to make a withdrawal, say I withdraw 450, that also works. If I check my balance, and there we are. So I think this is a very elegant language when it comes to object orientation and abstractions. Writing these 5 files and understanding how all this works, being that I had never written any C++, took me just 2 weeks, and that's not full-time reading and programming. Those 2 weeks is max 1 hour every 2 days, because I have a full-time job. So This is a good language to pick up, I think. And yeah, give it a go. See what you think. I don't know what I'll make with it, but for now, my eyes are set on embedded systems. Probably I can get to model much more complex simulations than an ATM. And what caught my attention is actually the size of the executable. Let me choose option 4 to close this. There we go. And after it closes, uh, I want to check the executable file such that you have an idea of how big this program is. So this is the ATM simulation. Just give me a second. And here it is. Unfortunately, you can't see this. But if I check how big this is, it is just 100 kilobytes, 100 KB. So for a program that's running 5 files, 2 headers, 3 source files, and this is all without any manual memory management or trying to be very strict. I believe if I pay attention to those details, how I'm passing the return types and calling functions, if I use pointers and all that, this could be even smaller perhaps.